We're going to work on section 1.1. I've got statistics and statistical words all over the place. Chapter 1 is really about vocabulary. So I'm going to work my way through these slides, but you also have the chapter 1 flashcards. You really need to look at that because that's going to help you practice this vocabulary. All right, so the first word is data. Data can be all kinds of things. It can be observations, it could be counts, it can be measurements, it can be responses. You can do a survey where you ask people, like this one, it says more than 7 in 10 Americans say a nursing career is a prestigious occupation. Well, they went around and asked people that. The second one is social media consumes kids today as well, as more score their first social media accounts at an average age of 11.4 years old. Again, they did a survey or they did an observation. They checked inside the social media. So data can be lots of different things. Another interesting thing about data is that word is both singular and plural. All right, statistics. We deal with statistics all day long. You just don't realize you do. Right now, we're going through this interesting time in America. There's statistics all over the news. So statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So it's very important all the way along. If you go to grad school, you'll be doing studies yourself, and you have to make sure that you have collected the data properly, that you organize it in a way that other people can understand it. You then are going to analyze it. And at that point, you have to figure out if you had a good study or not, or whether you need to go back and tweak something. Finally, you're going to interpret, and then you get to share all of that. These are two very important words. We're going to use these all the way through the semester. So the population is the collection of all outcomes, responses, measurements, or counts that are of interest. So the population is always going to be very big. A sample is a subset or a part of the population. So what happens is we have to have samples, because if I wanted to look at everybody in America, I really couldn't do that, right? Well, we try with the census, but it doesn't happen. So in order to talk to every single person in America, that would be a really hard thing to do. That would be our population. So what we do instead is we do a sample. Maybe we talk to every third person, or maybe we talk to so many people out of each state. And then we try to see what the data looks like based on the sample. It's not perfect because we didn't get to talk to everyone in the population, but at least hopefully we had a pretty good subset. So the population is going to be everybody. The sample is going to be just those people that you're able to talk to. So that's going to be a subset. Let's take a look at this problem. It says, why is a sample used more often than a population? So A is, it is usually impossible to count the entire population. That's actually true. That's like my example of trying to talk to everybody in the United States. The next one says sample statistics are more accurate than population. No, that is not true. If we could talk to everybody in the United States, that would be much more accurate, but we cannot. All samples are representative of a population. That's true, they are representative, but that doesn't mean that the population does not need to be used. The problem is we might not pick that sample. We might not talk to enough people, or if we're trying to find somebody's favorite meal, and we're trying to say that the favorite meal across the United States is barbecue. Well, if we only talk to people in Texas, then yeah, that's probably going to happen. But if I'm able to talk to people all over the United States, we're going to have all kinds of things. We are not just going to have barbecue. So the sample, you have to be careful, and we'll talk about that later, of how you set up your sample, but it really is a representative of the population. But if we can use the population, we would definitely want to. And finally, inferences cannot be made when using the population. That's not true. If we can use the population, that would be terrific. Sometimes we have to be careful if we're using a sample, but we'll get to that later. Okay, so it says in a survey, 834 employees in the United States were asked whether they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population and the sample. Okay, so the population would be all employees in the United States. Okay, of course, we can't talk to all employees in the United States. So instead, they did a survey and they talked to 834 employees. So that would be the sample. Okay, so population would be the total. That would be all employees in the United States. The sample would be the 834 that we actually did talk to. And so you can see we have a Venn diagram here. The population is the entire box, and that's all employees. And then within, we have a subset, and that's the responses of the people we talked to in the survey. And then, of course, we have people that we didn't talk to. Right, so you do have to watch what's going on because the population can be lots of different things depending on what we're looking at. So in that last slide, we were looking at all employees in the United States, but we could say that the population is everyone in California because we're only going to look at California, or everybody who works in the healthcare industry. So we do have to, a problem has to give you some insight of what the population would be. And if you're setting up your own study, you would have to figure out what you want your population to be. All right, so let's work on deciphering these. We want to determine whether the data set is a population or a sample. So it says the salary of each baseball player in a league. Okay, so each is like all. So if we're looking at the salary of all baseball players in a league, that's going to be a population, okay, because it is the collection of salaries for all baseball players. B says sample because it's all the baseball players, but there are the sports. Okay, we're going too far with that one. Plus, if it's all the salaries, it would be a population. Sample because it is a collection of salaries for some baseball players in the league. No, it doesn't say some. It says each, which means the same as all. And finally, population because it is a subset of all athletes. No, because population's not a subset. So the answer would be A. All right, same thing. We're looking for population or sample. The salaries of 5 baseball players on a team of 25. All right, they already told you that's a subset, right? Because we're only looking at 5 out of the 25. So we know it's a sample. B says a sample because it is a collection of salaries for all members of the team. That doesn't work. All would mean that we have the population. D says the sample because the collection of salaries for 5 baseball players is a subset for all baseball players on the team. So the answer would be D. Okay, so here's a Venn diagram. It's got the income of homeowners in a certain country, and then it has the income of homeowners in the country who have a garage. Okay, so the large box, the income of homeowners in a certain country, that's going to be your population. And then your subset inside, your blue rectangle that's completely inside the population, that's going to be your sample. So those are, you're only going to talk to people who have a garage. Okay, so here's a real life example of where we use statistics all the time. In factories, we have quality control managers. They cannot check every single product that comes off the line. Like this is looking at tomato sauce. So you have a machine that fills these bottles, and the quality control manager, there's no way that he can check every single bottle coming off the line. So he just randomly selects, like maybe he goes down there every hour and checks 2, or, maybe he goes, so many in the morning and so many in the afternoon. But this says a quality control manager randomly selects 30 bottles of tomato sauce that were filled on November 18 to assess the calibration of the filling machine. So we're going to look at this later in the semester, because if these bottles are starting to not be filled enough, then we have to calibrate the machine, because it's really frustrating to buy something and it's not filled all the way, or like cereal and there's hardly any cereal in there. Okay, so this is on November 18th. Therefore, everything's going to be about that date. So for the population is going to be every single bottle of tomato sauce that was produced on that day, on November 18th. So in that plant, every bottle of tomato sauce, that would be my population. That's my everything, right, for that day. The sample is going to be the 30 bottles that he randomly selected, but on that date, right? It's not bottles that he selected on a different date. It's all tied to that date. Okay, so I told you there's lots of vocabulary, but when you do your flashcards, it'll all make a lot more sense. Right now, it just seems like probably blah, 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 blah. But when you look at the flashcards, it'll help you remember some of this. Okay, so a parameter is a numerical description of a population characteristic, and a statistic is a numerical distribution of a sample statistic. Okay, so that example where we talked to 834 employees, right? We surveyed them to ask if their job was highly stressful. That was a sample, right? So therefore, that would be a statistic. Okay. If 834 had been my population, then that description would be a parameter. We're going to look at more in part 2, but I just wanted to show you the way I remember this is that we have parameter goes with population and statistic goes with sample. So you've got the letter P with the letter P and the letter S with the letter S. All right, so let's move on to part 2.